Hello friends, welcome to my YouTube channel Knowledge and Education Hub. This is new series of lecture module for GATE year 2021. In this series of lecture module, we will cover all theory part of GATE exam and also cover the numerical question. If you are new on my YouTube channel, please like, share, subscribe and press the bell icon button for knowing the latest video related to GATE exam. Okay. First lecture is cover the introduction part of the igneous petrology. In this lecture video, we will see we will understand what is the igneous petrology and terminology related to the igneous petrology. Let's start. First is the igneous rock. Igneous rock is the acronym of the two words. First is the igneous and second is the OUS. Igneous means fire and OUS means rock. That means the igneous rocks come from the fire, and in a well-mannered statement, the rocks that are formed from the crystallization of the magma is called the igneous rock. And what is the magma? Magma is the hot molten material. When the earth's surface, beneath the earth's surface, the hot molten material is called the magma. When these hot molten material come to the earth's surface, then it is called the lava. Two types of the igneous rock. First is the extrusive igneous rock, that is called the exterior. Intrusive igneous rock, that is called the interior. Igneous rock that solidify into the rock beneath is called the intrusive igneous rock, and extrusive igneous rock that is solidified at the earth's surface or near the earth's surface. The property of the intrusive igneous rock, it is a coarse grain, cools slowly, and a famous example of the intrusive igneous rock is the granite. Extrusive igneous rock, it is an extrusive exterior called igneous rock that solidify into the rocks on the earth's surface. It is called fine grain and cool very quickly. It's a quick quenching effect, so the quick quenching effect and so the glassy texture. What is the texture in the igneous rock? We will see in later lecture. And the famous example of the extrusive igneous rock is the rhyolite. Intrusive igneous rock is a type of rock that solidifies into the rock beneath or surface, coarse grain, cools slowly, and the famous example of the intrusive igneous rock is the granite. Here the composition of the extrusive igneous rock is the potassium feldspar, quartz, plagioclase. In this picture you can clearly see that the grains are very big, and the main property of the intrusive igneous rock is the coarse grain, and a special type of texture is the interlocking texture, and that is the grains are interconnected to each other, and is called this type of texture is called interlocking texture. We will see in later lecture texture in igneous rock. And the second is it cools very slowly, and this is the reason why the grains are very big. An example of the intrusive igneous rock is the granite. How the igneous rock forms? From this picture you can clearly understand how the igneous rock forms. This is the magma chamber where the magmas are generated, and when the liquid magma rises up and consolidated here, and this is the very deep seated part of the earth's surface, then this is the rock is called the plutonic rock. And here the one from this picture, here the one important property of the plutonic igneous rock, which is very deep seated rock, and you can see the important property of the deep seated rock is a euhedral texture. Here in this picture you can clearly see the grains of the this rock in a regular shape, which dimension in a regular shape. It is not a zigzag or irregular, which means that the deep seated rocks are a regular texture, shows a regular grain of the regular texture, and with a special name is called a euhedral. Euhedral means a regular shape based grain, and it shows a very high pressure and temperature. So the rocks are the grains of the rocks are formed in a euhedral shape. And when the rocks are formed here, then the rocks are called hyperbasal, and the grains are the very big grain because it cooled very slowly. And here the rocks are and the temperature is high, but the pressure is low in comparison to this. Here the pressure and temperature both are the very high, and that is the reason why the euhedral shapes are formed. Here the not euhedral but the big grains are formed like pegmatite. What is the pegmatite we will see later. And here there is a surface igneous rock, and this is the maybe classic texture or the surface igneous rock, also called a volcanic igneous rock. Here the pyroclastic deposit, pyro means very high temperature, and clastic is a rock fragment. When the very high temperature rock fragments are settled down and deposited, then this is called a pyroclastic deposit, and there is a flow, and it's called the pyroclastic flow. And here when the rocks are formed at the near the earth's surface is we show a very fast cooling and it's a quick quenching effect, and so a special type of texture is called a glassy texture. An example of this glassy texture is a rock type is a rhyolite. Origin of the magma. Where does the heat come from that melts the rock? How the magmas are generated? Where the heat source? Inside the earth's surface there are 106 elements are found on a periodic table. And in this mineral elements, some of the elements are the radioactive elements, and this radioactive elements is the main source for the heat generation, because these radioactive elements necessarily disintegrate and converted into the heat energy and others daughter element like uranium finally converted into the lead. And this, because the equation E is equal to mc square, when the mass is converted into the energy, then in a light, then a huge amount of energy is generated, and hence the main source of the magma heat source is the radioactive elements. Decay of the radioactive elements. Factors that affect the magma formation: the temperature increases with the depth, pressure increases with the depth, the normal thermal gradient of the earth beneath the earth's surface is 1.5 degrees centigrade per 3 kilometer. Water content, when the water is present in a mineral, then it's decreased the melting point. And mineral composition, different mineral composition formed at different temperature and pressure. Characteristic of magma: slushy mix of molten rock gases and mineral crystal. Common elements of the magma is the oxygen, silicon, ammonium, iron, magnesium, calcium, potassium, sodium. Compounds of the magma on the basis of the silica percentage is the most abundant. Greatest effect of magma characteristic: effect melting temperature, viscosity of magma. Types of magma is based on the amount of silica. It's a percentage type of amount of inside the magma based on the silica. First, the basaltic, andesitic, and rhyolitic. The percentage of the silica and rhyolitic is very high, then andesite, and very less in basaltic rock. Next is the rhyolite in 70% silica percentage, andesitic is 60%, and basaltic in rock in 50% silica percentage. Melting of rock. Does a rock melt like an ice cube all at the same time? No, it's not behave as an ice cube, because rock is a composition of the mineral or minerals, and every minerals have a different melting point, so the rocks does not melt as an ice cube. Rock melts according to their melting point because it's a composition of mineral or minerals. Example, ice cube with wax, which would melt first, ice or wax? Obviously ice will melt first, because ice has a melting point is lower than wax. After the melting of the ice, wax will start to melt. This example known as the partial melting. Partial melting, some minerals melt at the lower temperatures and other minerals remain solid. Think of a stew. Think. Fractional crystallization. Opposite the partial melting, last to melt are first to solidify. That is the crystallized. Partial melting and fractional crystallization we will see in a later lecture video, and this is the introduction part for your only information. Come to the Bowen reaction series, another Bowen Canadian geochemistry. Geochemistry in 1990 started that as a magma pulls minerals from its predictable patterns, known as the Bowen reaction series. It's a very well diagram, very good diagram for to know the understand the behavior of the magma mystery. But there are many drawbacks of this Bowen reaction series. First is it does not consider white silica deficient rock, feldspathe white. Second, it does not show the effect of the water content in the mineral, because the presence of the water, melting point is will decrease. And third is the main important, it does not include the bacterial activity of the inside the earth's surface. Okay, let's see the Bowen reaction series. Two branches. First is the feldspar branch, that is the continuous gradual change of mineral composition from calcic feldspar to sodic feldspar, that is the alkali feldspar to albite feldspar. Iron rich mineral, not alkali, sorry, that is the calcic feldspar to albite, that is the anorthite to albite. Iron rich minerals and abrupt change of mineral type. From this diagram, this is the Bowen reaction series diagram. Here the magma type. First is the ultramafic peridotite olivine crystallized, then pyroxene crystallized, then amphibole crystallized, finally biotite mica crystallized. And this series is called a discontinuous series. And this is a continuous series from anorthite, that is the calcium plagioclase, to sodic plagioclase. This series called a continuous series because it shows a solid solution series, and this is not a solid solution series, so it is called a breaking point series. Here the increasing resistance of weathering, which means the olivine is very less resistant to weathering, and biotite mica is a very high resist to weathering. And the rock formation, the granite, rhyolite, ultramafic peridotite for olivine, basalt gabbro for pyroxene, andesite diorite for amphibole. Finally, we have discussed the granite for the potassium feldspar, muscovite, and then quartz. Here the calcic feldspar is the 100% starting with the calcic feldspar, that is anorthite crystallized quartz. Here the temperature is very high, here the temperature is less. It means the quartz is crystallized at a very lower temperature, and olivine and anorthite, that is the calcic feldspar, crystallized at a very higher temperature. Olivine also is starting that form at the 1800 degrees centigrade and come to the 1557 degrees centigrade. Here it's also very come to the very scale is increasing due to for olivine. Come to the next point. Continuous change first for feldspars. Continuous change first feldspar are rich in calcium and finally rich in the sodium, increasing a cooling continuous. Last feldspar to form a sodium rich sodium. Here in intermediate form, calcium plus sodium, here calcium rich, and finally, and this shows a in equilibrium crystal behavior, that is called the corona texture. And percentage of silica is increasing from calcium rich to sodium rich. If a question is will ask in gate in which type of percentage of silica is high, then the sodium silica percentage is high, and temperature is decreasing, calcium is decreasing. For the discontinuous series, magnesium cools around 1800 C when the olivine crystallized. This continues up to the 1557 degrees. Olivine is a composition of phosphate and phthalate. Phthalate is the composition now for iron, and phosphate is a composition of magnesium. Now pyroxene begins to form all olivines that was formed in now turned to the pyroxene. Quartz is the last to form because of silica and oxygen are the last to crystallize. It is continuous series, and silica is increasing because up to the quartz, from olivine to quartz. Here the one is question, why we do find olivine, why the first crystal generated in the magma chamber is the olivine. As we have discussed, the olivine crystallized from the melting point of olivine is the magnesium cools around 1800 degrees centigrade. That means the olivine comes up to the 1557 degrees. At this high temperature, when the magma temperature is very high, when the magma comes due to cooling effect, magma comes to this temperature, the first crystal reach to this temperature, the first crystal match from the temperature point of view of the magma is the olivine. Hence the olivine first generated. I hope you will understand how the magmas are, why the magmas are generated first. Here the magma, and due to cooling effect, the first the melting point of the olivine is very high. No mineral will show this type of melting point. So when the magma cools down and come to reach of melting point of the olivine, then the olivine has formed and settled down, and here the early crystallization. When the later deformation is squeezed, remaining the liquid from the magma is sifted and crystal has formed. Four main groups of the igneous rock based on the magma type, mineral composition. First is the felsic, high silica content, light color from thick and slow moving magma, contains low amounts of calcium, Fe and magnesium dominant minerals, quartz, potassium rich feldspar, example granite, pumice, rhyolite, and second is the intermediate, moderate amount of silica mixture of colors, dominant minerals, sodium and calcium rich feldspar, example andesite and diorite. Mafic means dark, felsic means light. Mafic low silica content, dark color, rich high levels of Fe and magnesium formed from the thinner, more fluid and hotter magma than the felsic rock, dominant minerals of hot blend, calcium rich feldspar, example basalt and gabbro. Basalt is a volcanic rock, gabbro is a plutonic rock. Similarly, andesite is a volcanic and diorite is a plutonic, granite is a plutonic and rhyolite is a volcanic. Pumice is a white rich igneous rock. Ultramafic, very low silica content rock, dark color, high levels of Fe and magnesium, iron and magnesium, dominant minerals, olivine, pyroxene, example peridotite and dunite. Next is the classification of the igneous rock. Igneous rock classified on the basis of texture. Igneous rock texture classified on the basis of four types. First is the shape, size, crystal growth and mutual relationship of the grain to grain. Igneous rock texture, crystal size is detected by the rate of the cooling of the magma body. A slower cooling rate results in a higher mineral crystal being formed in the rock as they cool. Porphyritic texture, large crystal surrounded by the fine grained rock. The rock initially cools slowly to form a same large crystals and then cools quickly to form the fine grained rock surrounding them. In simple word, porphyritic texture, when the large grains are surrounded by the small grains, is called porphyritic texture. While it is formed inside the earth's surface, when the magma cools, then it's cool very slowly and it prefers the large grains of the crystal. When due to any reason sudden come to the magma on the earth's surface with this crystal, then the cooling is fast in comparison to the deep-seated magma. Then it prefers to the small generation of the small crystal, and these crystals are surrounded to the large grain. hence the porphyritic texture are formed, and this is the reason for the porphyritic texture. Classification of the igneous rock. From this diagram you can easily see. First, lower temperature at 700 degrees centigrade, and here the higher temperature 1200 degrees centigrade. Lower temperature shows the felsic rock, and intermediate temperature shows the intermediate mafic rocks, and ultramafic rocks shows at the very high temperature. Either here the felsic rock shows dominant of the sodium, here ultramafic shows the dominant of the potassium, and intermediate and mafic so the potassium, also mafic shows the dominant of the potassium, intermediate shows the dominant of sodium and potassium both. On the basis of silica weight percentage, 70 the silica felsic and 42 ultramafic, intermediate for the 50 of 60, and mafic for the 50. Is a percentage of the mineral by volume, coarse grain, and fine. These are the rock of the volcanic igneous rock, and these are the intrusive igneous rock, that is the plutonic igneous rock. Sodium rich muscovite for the amphibole, it's a intermediate, it's a very dominant of the sodium and potassium. Temperature is between almost 900 to 1000 degrees centigrade. For come to the muscovite or orthoclase feldspar, that is the felsic rock, and here the temperature is 700 degrees centigrade. That's the rock is the granite and diorite. For ultramafic rock, the temperature is 1200 degrees centigrade. The olivine is the main rock type, and for this is the peridotite, and dunite is also, it's a rare type. For this the dominant element is the potassium content in comparison to sodium. The scheme for the igneous rock classification, you can easily seen by the igneous rock classification from this diagram. First, starting with the crystal size, description. First, texture, that's a glassy, fine, coarse, very coarse. Glassy texture shows the non-vesicular and vesicular, that is the gas bubbles. Fine, that is the less than 1 mm. Coarse, 1 mm to 10 mm. Very coarse, 10 mm to or larger. Grain size is divided into the non-crystalline, less than 1, fine, that I have discussed. Then the very coarse grain, that is the more than the 10 mm, is the pegmatite. A pegmatite is a special type of texture. It is formed in the granite rock. Then coarse grain, that is the rock type is the granite, diorite, and gabbro. These are the intrusive plutonic igneous rock, and the crystal size, grain size is 1 mm to 10 mm. Then fine grain vesicular rhyolite, vesicular andesite, scoria, vesicular basalt, less than 1 mm, fine, and this is the extensive volcanic rock. Glassy is non-crystalline basaltic, vesicular basaltic glass. Obsidian usually appears in the black color. Pumice is a void species, that is the bubbles are present, vesicular gas packets. Now igneous rocks with the intergrown crystals, and this is the intergrown crystal. Non-intergrown is connected with the cement where it was formed. Also at the volcanic extensive igneous rock is this type, which we have discussed. Intrusive igneous rock this type, that is the plutonic rock, we have discussed. Bubbles, yes, vesicular, which we have discussed. Next is the non-vesicular, which we have discussed. Why the non-vesiculars are present? Color is the light color shows by the mafic, and dark color, light color shows by the felsic, and dark color is shows by the mafic. Lightest one, here is the darkest one. Very light is the pegmatite, granite, rhyolite. These are the felsic and very light. And here the gabbro and this, and the rock composition of the potassium feldspar, quartz, clear to white, quartz and precious feldspar, biotite, black, amphibole, black are present. These are the intermediate light rock, not very light, and the composition has changed. On the basis of the composition, you can classify this. And the near to the intermediate, here come to the intermediate rock, that is the andesite. Andesite, diorite, that is the intermediate, which is the composite. The plagiarized feldspar are dominant, then the biotite, then amphibole. Come to the dark color mineral, that is gabbro basalt, the dark color mineral and mafic type of mineral. Darkest color, here the dominant is the pyroxene. Now comes to the density, where the dark color mineral shows the high density and light color mineral shows the low density. Intermediate and medium density and high density. In high density, the olivine is the dominant rock, and peridotite and dunites are the rock which have a very high density, and is a mafic type of rock and very dark color. On the basis of this diagram, also find the identify the rock and percentage of the minerals. The rhyolite, you can calculate the percentage on the basis of this. This is the amount of plagiarized feldspar in the rock, and this is the amount of the rhyolite in the rock, and 25% of the plagiarized feldspar, quartz and potassium. Practice for this for the light color. For fine grain rock also practice, you can calculate from this graph easily. Granite, take the screenshot of this graph and practice on your paper for the GSI and other written exam. For the gabbro basaltic rock, come to the igneous rock resources for ore deposits, welding materials and other uses. Veins, sticks of the valuable for ore deposit. Igneous rock, the valuable metal within a mineral created when a metal rich fluid such as a gold quartz goes through the fractional crystallization. The mineral quartz has a lower crystallization temperature and thus solidifies before the gold. The gold remains liquid and settles between the quartz crystal, forming gold veins. Pegmatite veins that with extremely large grain crystal creates some of the world's most precious gems. Kimberlite intrusions of magma cooled deep within the Earth's crust usually find diamonds with the kimberlites, named after the location of the first discovery, Kimberley, South Africa. Building materials, many igneous rock also used for the building material are fairly weather resistant. Granite building material, basalt, crustal may used for the gravel. And this is a short introduction for the igneous petrology. Now next lecture video we will discuss the topic for the in a deep topic for the GATE exam. If you enjoy this video, please like, share and subscribe and press the bell icon button for the latest notification of the GATE video. Thank you for watching this video.